Okay, welcome everybody to this mathematics video. This video is going to be specifically covering content regarding your grade 12 trig equations. Okay, and when I mean trig equations, I mean general solutions. Okay, so I just want to zoom in a little bit so that I can obviously write nicely. I can see things better as well. Okay, so remember in your general solutions, you're usually given some sort of, let's say, sine theta is equal to, let's say, the A. Okay. And what we'd usually want to do is isolate this theta, okay, so that we can get what we know as a reference angle. So to isolate that theta, we'd have to do the inverse of sine on this side to A, okay? So that theta, whatever this is equal to, is then going to be your reference angle. Right. Now, once we've found a reference angle, we're then going to draw like a small Cartesian plane. I'm going to just fill in some information, So our cos diagram, we know that in the fourth quadrant, cos is positive. In the first quadrant, all of the trig ratios are positive. In the second quadrant, your sine ratio is positive. And in the third quadrant, your trig ratio is positive. Okay, we can see here that our A, okay, is positive. So that means the angle can take place in those two quadrants. Okay, so we then know that, okay, we learned in reductions that this is 180 minus, and then theta just stays theta there. Okay, so then we can start creating our general solutions by saying that theta is equal to, let's do it in the first quadrant then. It's just going to be theta is equal to then whatever A is plus K360. Or rather, not necessarily whatever A is, whatever the reference angle is. So this angle over here. Okay, then in quadrant 2, I'm then going to say theta is equal to 180 minus my reference angle plus K360. Okay, now you learned this basic general solution in grade 11, I believe. Okay, and you should also remember that this K, remember, this is more of your I want to say constant, but it's not what you call it. It's basically like an increment, okay? So we can say that K can be 1 or 2 or 3, okay? And if you say 1 multiplied by 360, 2 multiplied by 360, 3 multiplied by 360, all of those numbers are then going to be multiples of 360, and basically just tells me how many times I go around that Cartesian plane, okay? So we're going to then start with the grade 11 work, grade 12 work, apologies. Okay, one last thing. If per se this A value had a negative, okay, when you find the reference angle, ignore the negative. So let me just write it here, ignore negative. Okay. But if it is a negative, that means that it's no longer going to be in the first and second quadrant. It's then going to be in what? It's going to be here and here. Okay, because those are the quadrants where sine is negative. Right. Okay. So when we want to solve with our general solutions, there are a couple of steps that we just need to revise. Okay. Firstly, you need to use trig identities. Oh my goodness, I don't know why it's just, okay, anyways. Trig identities to simplify equation. So in that example I just gave you now, this is really simple, okay? I could just take the sine to the side, okay? But in grade 12, you're going to have compound angles, double angles, and a lot more that needs to be simplified, okay? So you need to use your trig identities to simplify the equation first. Then you need to find the reference angle. Again, I just showed you how to find the reference angle. Then you used your cos diagram to find which quadrants the angle is in. And like we saw earlier, we saw that if the angle itself is positive, then we know, okay, if its sine is positive, then we know it's the first and the second quadrant. Okay. Then in some questions, they will give you an interval. And you need to find angles within that interval. I'll also show you how to do that. And lastly, you need to add multiples of the period. So what do I mean by this? I mean that if I say K360, okay, basically I'm saying K360, but it's K360 for sine and cos. Why? Because if you think of our sine and cos graphs, the period of a sine and cos graph is 360, meaning they repeat every 360 degrees. But when I'm dealing with my tan graph, I'm going to say 180. Why am I saying 180? That's because the period of your tan graph from trig functions is 180 degrees. Okay, and then lastly, you just simplify this expression. I know I said lastly for step 5, but simplify the expression. Now, what do I mean by this? A lot of times we'll have like 180 minus an angle. You need to simplify that. Okay, so let's move on then. Just want to go through my notes here. Okay, so let's look at an example. Okay, so per se, we have something like sine 2 theta over cos 2 theta, okay, is then, let's say, is equal to minus 4. Now, we have two different ratios here, and well, that's not going to really help us much, okay? But what I do see is a sine over a cos. The minute you see a sine over a cos, you need to immediately think tan. And what do we have here? The angle that we have here is 2 theta. That's the tan angle, 2 theta. Is then equal to minus 4. Okay, so then what I'm going to do is, I'm then going to take my tan to the other side, and leave it as 2 theta over here, obviously, and then take my tan to the other side, and now it will have to become the inverse of tan. So that is minus 4. So regarding inverses, just how you have a positive and a negative, they are inverses of each other, or you have multiplication and division, they are inverses of each other. If you have tan and tan to the minus 1, they are inverses of each other. Okay, so then you can put that into your calculator, but notice there's a negative. Ignore the negative. Okay, ignore the negative. You don't have to worry about the negative. Okay, so then you're going to get 2 theta is equal then to 75,96 degrees. Now, this 75,96 degrees is your reference angle. Okay, once you get theta, whether theta is attached to something or not, okay, if theta by itself is here, it doesn't have a trig ratio, you stop there and you find the ratio. Okay, sorry, not the ratio, you find the angle. Okay, and that will be your reference angle. So I'm not going to come here and divide by 2 just yet. Okay, that's going to take place later. All right. Now, I need to go onto my cos diagram. Oh, okay. Cos diagram. Okay, so I know C-A-S-T. Okay, this is a negative tan. Okay, so I know that tan is negative in this quadrant and tan is negative in this quadrant. I know that to reduce tan in this quadrant, you say 360 minus your reference angle. And here you say 180 minus your reference angle. Okay, so this is what? Quadrant 2, and this is over here, quadrant 4. Okay, so then let's go and find the general solution for that. Okay, so let's do quadrant 2 first. So we're going to say 2 theta is equal then to 180 minus our reference angle. What is our reference angle? We just found it here. That's 75,96 plus K360. Okay, when I say K360, it's literally just K multiplied by 360. Okay, you don't really need to show that there because we know it's there. Okay, so then we're going to just simplify here. I just want to get my calculator real quick. And that's 180 minus 75.96. And then that is going to give you 104,04 plus 360, K360. But now this is not entirely simplified. Why? Because I need to get theta by itself here, but I still have 2 attached to theta. Okay, and this is where we can now divide by 2. Okay, so theta is then equal to, I'll just divide that on my calculator. That is then going to be 52,02 plus K180. Okay, and this makes sense, right? Because if we think of trig functions, okay, if it is a double angle, so like what tan to theta, for example, okay. Oh, I just made a huge mistake here. Okay, not a huge mistake, it's fine. I'm so silly. Okay, I just realized now. This 360 is supposed to be 180 because remember the period of your tan graph is 180. Okay, so that's 180. Okay, then 180 divided by 2 is 90, obviously. Evan, you were working just fine earlier. Okay, is 90. Yay, 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 yay. Okay, there we go. Okay, so that is the general solution for the quadrant 2. Okay, now quadrant 4. Okay, and just by the way, these are just the Roman numerals, okay? If you want to say quadrant 2 instead of making it fancy like that, it's okay. You don't have to say that. You don't necessarily get a mark for whether or not you say the Roman numeral or not. Okay, but obviously just do whatever your teacher says you must do. Okay, next we have 2 theta is equal then, so this is the fourth quadrant, so that's 360 minus our angle, which is 75,96, plus k, is it 360 or 180? Okay, I hope you said 180. Okay, so that's 360 minus 75.96. And then that's going to be equal to 284,04 plus K180. Okay, but now again, this 2 is obsessed with this theta. We need to, divide it out. Okay, so then let's divide by 2 on both sides. Okay, divide by 2. So that theta is equal to 142,02 plus K 90. Not so bad, was it? Okay. Now we are going to move on with more questions. I just need to find the questions that I want to do. Of course. Okay. So, let's see. Okay, here we go. So we're going to first start off with some really basic equations. Okay, so let's say we have sine theta is equal then to 0, 3. This is super easy, okay? This is already reminding us of that earlier example where I'm saying sine theta is equal to some sort of angle, let's say A. Okay, remember the steps we took there. So then theta is then going to be the inverse of sine, okay? And just how the inverse of tan is tan to the minus 1, the inverse of sine is sine to the minus 1. And then we just enter that into our calculators. Okay, so shift sine 0.3, that will then give me 17,46. Okay, this over here is our reference angle. Okay, now you tell me, what quadrant is this in? Okay, if you said this quadrant and this quadrant, you are correct. Okay, and remember we reduce in this quadrant between 180 minus, and we don't reduce in the first quadrant, okay? We don't reduce in the first quadrant because remember the first quadrant is 0 to 90 degrees. Okay, that is an acute angle. All right. Now, when we reduce quadrant 1, we're just going to say theta is equal then to 17,46 plus K 360. Why am I saying 360 now instead of 180? Okay, if you said it is because it is sine, and in a sine graph, the period of a sine graph is 360. Okay, you are then correct. Well done. Then we're going to move on to the second quadrant. Theta is then equal to 180 minus 17,46 plus K 360 is then equal to 100 minus 17.46. I'm just entering into my calculator. Ooh, almost lost it there. 162,54 plus K 360. Not so bad, eh? Not so bad. Okay. So now we're going to move on to another example. Now the example I'm going to show you now is going to require some simplification. Okay, maybe the reason it keeps jumping back is because I've used up all the space. Okay. Right, B. So then that's tan 3 theta minus 15 is equal then to negative 2,5. Whoa. You're probably thinking, yeah, man, like what is happening here? Okay, don't worry. It's fine. All we can do is just take that tan over. Okay, just take that tan over so that we have 3 theta minus 15 is an equal to tan minus 1. And when we have a negative, what happens? We ignore it, okay? We ignore that negative when we are finding the reference angle. Now, because there are no ratios on this side, we are going to leave this side as it is. If there were ratios still on this side, then we have to sort some things out, okay? But there's no ratios on this side anymore. I don't know if you guys can see which side. On this side, there's no more ratios on this side anymore. So that means we're going to leave this side as it is, okay? And this side is going to give us my reference angle. So then your reference angle is going to be equal to 68,20 degrees. Okay, now we can finally look at that negative when we look on our cast diagram. Okay, so how about this time, instead of writing cast on the diagram, let's try and think in our own minds. Okay, do we remember how the cast diagram looks in our heads? Okay, it's like you can think of that C, A, S, and T. Okay, so then we know that it is negative over here and it is negative over here. Okay, let's see if we draw cast again. Yeah, am I right? Am I right? And yes, I am right. Okay, so once again, we reduce our angles in the sine, not in the sine quadrant, listen to me, in the second quadrant by saying 180 minus whatever your angle is. And then we reduce using 360 minus in the fourth quadrant. Okay, so then we're going to say 3 theta minus 15 is then equal to 180 minus 68,20. And this is a tan graph. So what are we going to say? We're going to say plus K1 8 because that's the period. If you do so, plus 360, I won't lie. I have done that before in tests, and they haven't necessarily marked it wrong. Okay, so I don't think it is a problem if you say 360, but just for the sake of accuracy, let us remain accurate over there. Okay, so then what are we going to do? We're going to simplify here. So then we're going to take this minus 15 over. So we're going to say 180 minus 68,20 or 720. Yeah? And then it's going to become a plus 15. Right? And then that is going to then become 126,80. Just want to double check if I actually did this right. Okay, and then plus 180. But now we still have this 3 theta over here. So we're going to divide by 3 the entire way. So that theta is then equal to 42,27 plus K 60. Okay, so that one was a bit of a big one for just even one quadrant. Okay, but it's not so bad. It's not so bad. Okay, so then quadrant 4, let us take a look. If I say 3 theta minus 15 is equal to, okay, remember this one is 360 minus, so 360 minus 68,20 plus K180. And that's 3 theta is equal then to 360 minus 68,20 plus 15 on this side. Because remember, if I plus 15 on this side, to get rid of that minus 15, I must plus 15 on this side as well. Okay, plus K180. Okay, and that's going to give me 306,80 plus K180. Okay, and then obviously we still have that 3 theta, so we need to divide by 3 on both sides. So we can get theta by itself. So then we're going to land up with 102,27 plus K60. Right, okay. I'm going to try and find like a... Okay, yeah, I found another one that is nice. Okay, so in previous grades you may have heard of, you know, the fact that you can divide by cos, right? Okay, so I'm going to show you what we can do here. Okay, so the first thing that I want us to do here is, hold on, I'm just looking at this question now. Okay, is we're going to then take this 3 cos over. Okay, and that's going to become a minus cos. Okay, so minus 2 sine theta is going to become minus 3 cos theta. Okay, and yes, you can go through the whole shebang of minus 1, okay, and then 2 sine theta is equal then to 3 cos theta. Why did I divide by minus 1? Because I don't want to deal with negatives, okay? I do not want to deal with negativity today, all right? So then we're going to divide by cos on both sides. Why can I divide by cos on both sides? Because we just can, okay? But the reason why I specifically want to divide by cos on both sides is because if I have sine theta over cos theta, what is that? That's tan theta, yes. So that's 2 tan theta is equal to 3, because remember it was just that. Okay, so then we can divide by 2 on both sides. So that tan theta is equal to 3 over 2. Whoa, it's getting a bit squished there. So then I can get theta by itself to find a reference angle. Okay, and when we bring tan over, okay, and we say tan to the minus 1, okay, what do we call this version of tan? Yes, we call it the inverse. Okay, So then tan to the minus 1 will then give me a reference angle of 56,31. Okay, and then if you look on our little cast diagram, we know that tan is positive here in the third quadrant and tan is positive here in the first quadrant. In the first quadrant, we can just leave theta as is, and then in the third quadrant, we say 180 plus to reduce it. Okay, so then if I say theta is equal to 56,31 plus k, this is tan, so you're going to say 180. All right, and this is for quadrant 1 because we just leave it as is. Okay, and then quadrant 2, we're going to say theta is equal to 180 plus 56,31 plus k3, not 360, I keep on forgetting. Okay, 180, so that theta is equal to 236,31 plus k 180. All right, so it's once we simplify the actual expression, the general solution becomes very easy. Okay, let's do another one. Okay, let me try and find one that's kind of like, ugh. Okay, let's do this one here, where we say cos theta plus 1 is equal then to 3 sine squared theta. Okay, so how are we even going to do this? Right, now when we can't really divide by cos. Why can't we divide by cos? Okay, because of that plus here. Whenever you see a plus and minus, basically this is a binomial. Okay, you bracket it. Okay, I like to call it a strict parent. Okay, strict parent. The strict parent is not going to allow the cos to go anywhere. All right, it's going to be housebound between these two brackets. Okay, so what can we do then? Well, this sine squared theta, if we think of the rule sine squared theta plus cos squared theta is equal to 1, then we know we can then rearrange to say sine squared theta is equal to 1 minus cos squared theta. Okay, so then that is precisely what we're going to do. We're going to say cos squared plus 1 is equal then to 3, and we're going to replace the sine squared theta with 1 minus cos squared theta. So essentially, if we cannot get maybe a tan, we need to make sure that it's either we're dealing with just sine or we're dealing with just cos. Okay, and in this case, because we can't really do anything over here, we can't really, replace this cos theta over here with a sine of some sort, but we can replace this sine with a cos. Okay, so that's exactly what we're doing over there. Right, don't worry, these little things are going to go away now. Okay, now we're just going to say cos theta plus 1. We're going to share this 3. I wonder why this is not disappearing yet. But anyways, so then that's going to be 3 minus 3 cos squared theta. Okay, are we verstaan? Hopefully. Okay, but now what I want to do, because I have a squared here, the minute you see a squared, you need to start thinking, okay, we're going to have to factorize. Okay, factorize. Okay, so what can happen here is I can either get possibly a difference of 2 squares. Okay, and looking at this already, I can tell I'm not getting a difference of 2 squares. Okay, I can either get the highest common factor, okay, potentially, or I could get a trinomial. Okay, and what is most likely going to happen is I'm going to get a trinomial. So let's simplify. Cos theta plus 1, I'm going to put it in standard form. So bring this 3 over, it's going to become a minus 3. Bring this negative 3 cos squared theta, it's going to become a plus 3 cos squared theta, and make it all equal to 0. Okay, now simplify. Okay, so I'm going to say, okay, I know that I need to put this in the right order just so it looks better. You don't have to do it. You don't have to put it in the right order, but it always makes more sense to put it in the right order. Okay, so then that's cos squared theta plus cos theta, and then 1 minus 2, that's negative 2. Okay, now factorizing with a trig ratio can become confusing. But what you can do is you can also just say, okay, my cos theta is equal to k. Okay, so then that is 3k squared plus k minus 2. Now that looks a lot easier, right? Okay, so for those of you who struggle with this, you can just do that, but I might just do it straight up like this, okay? So then we can say, okay, we'll just put 3 here, cos, and then let's put cos here. Okay, cos theta, obviously. All right, now, technically in front of this cos theta here is a 1. Okay, so basically what I'm saying now is what will multiply to give minus 2, but when we try and add them, it will give me plus 1. Okay, and that will be minus 2 plus 1. Why? Because minus 2 multiplied by plus 1 is negative 2. Okay, but minus 2 plus 1 is 1. Okay, easy. So then we can then simplify these. So then it's going to be 3 cos theta is equal to minus, say plus 2. Oh, sorry about that. Okay, and then we divide by 3. Divide by 3. Cos theta is then equal to 2 over 3. Okay, and then, or you can say that cos theta is equal to minus 1. Why? Because we just put that plus 1 over the equal sign. Okay. Now we're probably going to have, what, 4 different general solutions, because we might have 2 general solutions here for cos theta and 2 general solutions here. Okay, so what I want you to do is I want you to attempt to do the rest of this general solution for this question. Okay, and then the answer will be posted soon.